I'm doing fine. How are you?
Good. Just reviewing some of these problems coming up. Um, we'll get done with coordinate geometry today and get into counting and probability. And that can be challenging, that area. And then hopefully we'll have time to go through a test or two before we're done here.
That would be great.
Yeah. All right. Let me go back to a problem that I'm not sure we did correctly. I was looking at it after we got done with our session yesterday. And it was this circle. This seems to me the point we eliminated was C, 16, 8.
Correct.
Well, that point actually can be on this circle. Let's see, 6, 8 is the center. And it goes through the origin, so notice that the point 16, 8 is the key aspect of this problem is determining the radius.
Okay.
Okay? And from the dimensions of this point here, if that's 6, 8, then I can create a triangle whose sides are 6, 8, makes that 10. So now we know the radius of the circle is 10, and every point combination here has to fit the Pythagorean theorem.
Okay.
Well, 16, notice that 16 is only 10 away from 6. So the point 16, 8 would be on that circle.
Okay.
Okay. We could test it by drawing its right triangle, which means, but we don't know this dimension. So now that I think about it, we can certainly see visually that 16, 8 is going to be on the edge of the circle. 16, any other number, would not be. But this point right here would have to be 16, 8 because the radius is 10. So that point's on the circle, so is that, so is that. The only point that is not on the circle is D, minus 212. Well, it turns out that minus 212 is very close. It's right about there. So might not be perfectly evident that that would not be on the circle. Now, when I look in the answer book here, they did not go through why they said this point was not on the edge. They just said that's not on the edge. They drew the picture. They labeled all the points. The only way I really know how to do this problem properly is by using that equation of the circle that I was telling you about. So that you might want to memorize that.
Okay.
And use it, although I would be inclined, rather than trying to make sure you have this memorized properly and use it, if you can solve these problems visually, by all means do it. But in this particular case, you had a set of points. One was there, one was there, one was here, where visually you really could not distinguish which points were on the circle and which weren't. So the only way I really know how to do this problem is by using this. And using this method still requires you to figure out that the radius is 10. So you still have to use this triangle thing here. So anyway, I wanted to clear that up because I hate giving wrong answers to students.
Well, thank you.
Okay, let's see. Let's go to 7. Redraw this just because. Now these are fairly common problems also where you have a parallelogram. So again, let's try to approximate the points here. Minus 5 up 2. So that's minus 5 comma 2. Minus 2 comma 6. Well, that would be minus 2 comma 6. 5 comma 6. 5, 6. That's good. That means our parallelogram looks like it is parallel to one of the axes. And then 2 comma 2 be right about there. So this should be a relatively easy parallelogram to answer their 2 questions on. What's the area of this parallelogram? What's the general formula for area of a parallelogram?
I can't think of it off the top of my head.
What is it for a rectangle?
Length times width.
Okay, let's call it base times height. Same as length times width, only when you're dealing in the xy coordinate plane, we generally think of the vertical axis as height.
Okay.
So the area of a parallelogram is the same as the area of a rectangle. The difference is the height that we're talking about is the vertical height, not the slant height, which for this problem makes the problem easier. So what is the area of this parallelogram? What is the base? What is it from here to here?
Is 7.
Okay. What's the vertical height from here to here?
6.
It's 6 minus 2.
Oh, okay.
You see why? In other words, this point here is 6, and this point on the curve is 2 on the axis, on the y-axis. So this vertical height is just the difference between the two y's. So the area is 28.
Okay.
The perimeter is harder because to get the perimeter, we're going to need to know the length of that slant. And that's harder to get than the vertical height was. Let's see if there are any shortcuts. Let's see. This triangle is a 4. Aha, 3.
Okay, so the other's going to be 5.
Right. Now, had I not decided to try that shortcut, I would have had to do it the hard way using the distance formula. Let's just review again what the distance formula is. We know it's the square root of something because the distance is always the hypotenuse of that triangle.
So it's x2 minus x1 squared plus y2 minus y1 squared.
So in this case, it would be the square root of the differences in the x is 3, and the differences in the y is 4. So that would have been the hard way. In other words, had they given you numbers that weren't a perfect 3, 4, 5 triangle, you would have had to do it this way.
Okay.
Okay? But they're usually nice enough to stick little shortcuts in there that if you happen to check, you can speed up doing it the hard way. Check and see if maybe that isn't a 3, 4, 5 triangle or something, even an isosceles. Even if it turned out to be an isosceles triangle where this was 2 and this was 2, you'd have had a real quick method of coming up with that distance. So what's the perimeter of
It is 1424.
the perimeter? Remember that that little triangle we created was only part of the parallelogram. We only created that little triangle to figure out the distance of that side of the parallelogram. They want the perimeter of the parallelogram.
Okay. Aren't the two sides 5 and 5 and then the top and the bottom 7 and 7?
Yeah, what answer did you get?
I said 24.
Oh, excuse me, you're absolutely right. I don't know where I was getting my answer from. In my head, it was not 24. I apologize. Okay, let's go to the next page. More slopes. Lots of slope questions here. So that's primarily what coordinate geometry is going to be about, is slopes.
Yeah, I really need to practice on the coordinate geometry because this just doesn't come easy to me at all.
Okay. Well, the truly most important thing you can do with coordinate geometry is to be able to plot a point. If you can plot a point and you know about slopes, then notice these scales don't have to be the same. I could make this scale like that. Although in all of the ones you're dealing with, they're going to be consistent. In other words, the grid will be a square grid. Okay? So as long as I can give you an XY coordinate and you can plot it, can you do that?
Yes.
Okay. Everything else is based on that. In other words, for me to draw that picture, that's all I have to be able to do. And then once you have a picture, you have a parallelogram and it becomes a geometry problem.
Okay.
And that's pretty much the way it is with most of these. So let's look at this one. We don't need to draw this one. Number 9. So I have a point A comma B, and I have a point 1 over A comma B. What's the slope between them?
Well, B minus B over 1A minus A.
What's the numerator?
0.
What's the answer?
0.
Okay. Now, if it was 0 over 0, we might have a problem, because 0 divided by 0 is indeterminate.
Okay.
But they're not going to give you that. A calculus course might give you that, but you're not going to run into that here. And if they had it, what if it was the reverse? What if they said, what is the slope of this?
Then it's undefined because of the denominator being 0.
Correct. What does an undefined slope look like? It's a vertical line.
Oh, okay.
That's undefined slope. And it's all it means is it's infinitely large. Because as slopes, in other words, there's the slope of 1, there's the slope of 2, there's the slope of 3. As you get closer and closer to vertical, you're approaching an infinite number. The slope of 10 billion would look almost vertical, but not quite. Okay. Notice on that last one, what we did not want to do was fool around with the algebra involved in solving for the denominator. That would have been a total waste of time. As long as the numerator is 0, the slope is going to be 0. It's a little blurry. Can you read that okay?
Yeah, I can.
Well, it's minus c, comma c, and this is 3c, comma a. So tell me everything you know about this problem. What can you write?
I can write that I have a minus c divided by 3c plus c. So a minus c over 4c
Is equal to what?
1.
Okay, that's the key part. Because they told us the slope was 1. So we know that that equaled the slope, which equals that, which equals 1. So now we just have an equation that we have to solve. What are they asking us to solve? A in terms of c.
Okay, so we would have, let's see, a minus
Go ahead.
c equals 4c,
Uh-huh.
and then a equals 4c plus c, so 5c. A equals 5c.
E.
Okay.
Okay. Another equation where they give you an equation and they ask you to solve for the other variable in terms of one of these. So basically your ability to do algebra once you set it up. M is the slope of one of the diagonals of a square. What's greater, m squared or 1?
I have no idea. Can I just use numbers to plug in for m?
We don't know. Well, no, you can't.
No.
You kind of have to recognize from geometry what the slope of that line is. If I were to draw an XY coordinate scale running through here,
Oh, it's going to be 2.
what's the slope of a line that has a 45-degree angle?
It's going to be the square root of 2.
What's the slope? Remember, don't
I-
confuse this with dimension. They're not
Okay.
asking about the length of this line. What they're asking about is the slope of this line. In other words, the slope is the rise, this dimension, divided by the run, this dimension. Right? In other words, as we go up this amount, and we go over this amount. So what's the slope of this line?
I'm just going to say 1 over 1. I don't know.
S over S. Because it's a square, the height is the same as the base.
Okay.
So the slope of the diagonal of a square is always 1. This is always a 45-degree angle here. So 1 squared is equal to 1. This is kind of a trick question almost, because I'm guessing most people would do exactly what you did, which was view it as a geometry problem and try to solve for that distance.
Okay, so the slope of a diagonal is always going to be 1?
Yes, of a square. Notice,
square.
not of a rectangle. If I had a rectangle like that, and this slope here, that's not a 45-degree angle any longer. That's closer to like a 30. It could be anything depending on the relationship of the width of the rectangle to its height. So it's only a square where that diagonal is always 45 degrees and the slope of a 45-degree line is 1.
Okay.
It's also negative 1. In other words, that's also the diagonal of a square. Notice that the slope of the other diagonal is not 1. It's negative 1. And that's why the question here says m squared, to handle both the negative and the positive 1 slopes of the diagonals.
Thank you.
Actually, they're not correct with this problem, now that I think about it. Wow, and maybe I didn't have the right answer. Wow. What if the square looks like this?
Huh.
Now the slope of the diagonal is not 1 anymore. Wow, that means it's indeterminable. Let me check the answer on this one. I didn't even bother to check the answer because I was so sure. If the sides of the square are, yeah, D is indeterminable. If the sides of the square are horizontal and vertical, then it would be equal, but the square can be positioned in any place. So the diagonal could be any number. Ah, trick question. GMAT loves those.
Hey, but you figured it out that it was a trick question. That's good.
Well, even after I thought about it, I wasn't sure that that would be the answer. I mean, maybe implied was the fact that the edges of the square were parallel to one of the axes, but then I realized that there's no way you can imply that. All right, let's see. A minus B or 0? Am I missing some information here? No?
Well, it looks like A can be anything greater than 1, and so can B.
Well, yes, I agree with that. So the answer would be D.
Right.
They kind of try to fool you visually by making that line look like it's exactly 45 degrees. Oh, and it is. It is 45 degrees because it goes through that point and it goes through that point.
Okay.
So whatever the slope is between those 2 points, and notice that would be 1 minus 0 divided by 1 minus 0. Whatever the slope is between that 2 points has to be the slope anywhere on this line. So that has a slope of 1. Now, any point that is to the right has to be what? A has to be greater than B.
How come A has to be greater than B?
Well, slopes that are like this are less than 1.
Okay.
Slopes that are like this are greater than 1. So, if we were to look at that slope, we know it's less than 1.
Okay.
Only way it can be less than 1 is if A is greater than B, because the slope of this line is B divided by A.
Okay.
In other words, this point here is A comma B. Slope is rise over run. The other end is still at the origin. So B over A we know to be less than 1, and because of that, A is greater than B.
Okay.
So A minus B has to be a positive number. So quantity A is larger.
Okay.
Had they put the point on the other side of that line of known slope 1, in other words, had they put the point here, we know A has to be less than B. And visually, you can kind of see that. In other words, experiment with some points to the right. Well, if I put a point over here, the A measurement's much larger than the B measurement.
Oh, okay.
If I put a point right there, it's too close for me to tell. And if I put a point way up there, it's still too close for me to tell. So the only ones I can tell are the exaggerated ones like that. But the fact is that it's the same no matter where. A has to be larger than B. The x coordinate has to be greater than the y coordinate.
Okay. That makes sense.
The key really is figuring out that the slope of that line has to be 1. Now, at first I was kind of fooled because they didn't give us 2 points. They just gave us 1 point, and they make it look like it's 45 degrees. And then I realized they really did give us 2 points. They gave us this point, and they gave us that point, the origin.
Okay.
And that did allow us to calculate the slope of that line. Okay, the slope, this is line K, this is line L. They put a point in there, completely unnecessary. Visually, you should be able to tell which number is bigger. Now, so far we've only talked about positive slopes. So let's just go over this. Slope of that is 1. Slope of that is 1/2. Slope of that is 2. Well, on the negative side, there's your -1. What do you think the slope of that is?
-2.
Okay, that's all you need to know.
Okay.
The slope of this would be -1/2. So what of the slope of K compared to the slope of L, which is the bigger number?
K would be, excuse me, K would be larger because it's -1, not -2.
It's -1/2. There's K.
Oh, okay, 1/2.
And that's -2. So you're absolutely correct. -1/2 is greater than -2. Might not look visually like that would be the case. In other words, visually, most people would say the slope of that is steeper. And it is. The slope of L is steeper than the slope of K. But because they're both negative, the negative half is greater than the negative 2. All right. The slope of that line is negative 0.8. Which quantity is bigger, C or B? Okay, let's lay out the grid. We know that the slope is negative 0.8. Let's see, that's a number less than 1. So it's going to be flatter, right? In other words, if I look at this line here, which is the 45-degree angle, I know that the slope they're talking about goes like that.
Okay.
Okay, in other words, it's flatter more than steeper. You know what I'm saying by that?
Yes.
Okay. If it was negative 1, what would be the relationship between B and C?
Well, B is going to be positive. Well, no, not necessarily.
If it was, let me draw it like this. If it was negative 1, that's a 45-degree angle. That is an isosceles triangle where this dimension would be equal to this dimension. That's B, that's C. So if it were negative 1 slope, B would be equal to C. So given the dotted line is the slope that we really have, what is the relationship between B and C? Which one's bigger?
I don't get it. I don't understand.
Okay. Let's go back to the negative slope of negative 1.
Okay.
Let's pretend that our A and B are up there at this point here, and the C and D are right there at that point there. If that were the case, can you see where B is equal to C? The dimension on the y-axis would have to equal the dimension on the x-axis because we have a 45-45 right triangle.
Okay.
Okay, so in this case, B equals C. Now look at the triangle formed by the dotted line, which is the triangle we actually have. What can you say about B and C? In other words, this is now our point B, and this is now our point C.
So B is less than C.
Exactly. C is greater than B. So quantity A. And there's no way to tell visually because they've kind of drawn that slope as negative 1. Maybe not exactly. They may have actually drawn it as negative 0.9 or maybe even negative 0.8. But they drew it close enough to a negative 1 slope that you cannot visually answer the question.
Okay.
At least I can't. I can't tell that C is larger than B there. Now, you understand that C is this measurement here and B is this measurement here.
Yes.
But from that graph, I can't in my head tell that C is larger than B. So I have to go to this picture here. I'm trying to think if there's another way to solve this. I think this is actually the best way. And this kind of gives you, these last two questions were good in terms of understanding slope. The slope is hugely important. It's not probably clear why, but slope is the fundamental of differential calculus. Differential calculus is all about slope. Okay, if we have the distance from B comma 5 to C comma minus 3 is 10, and we know that B is less than C, then which is bigger, C minus B or 6? The question is, this is the last one in this section.
Okay,
So let's try to draw something. One point is B comma 5. Well, here's 5. We'll make B a positive number just for the heck of it. So we'll put B comma 5 right there. And C comma negative 3, well, we know the negative 3 part is right about here. I'll put it. And the C is greater than the B, so we have to be somewhere over here. Okay?
okay.
And furthermore, so this is I mean, the 2 points could be here and here, or here and here. The only thing we know is that C has to be to the right of B, based on this here. We also know the distance is 10. So, question becomes, let's complete that triangle, which is frequently what you do in coordinate geometry. What is the vertical dimension on that triangle?
I don't know.
Well, it's the distance from 5 to minus 3. In other words, this is 5 right here, and this is minus 3 right there.
Okay, so 8.
Okay, so if this dimension is 8, what is this lower dimension?
6.
Okay, now we can define what B is and C. Actually, we don't need to define that. What we need to know is the difference between C and B. What's the difference between C and B? Since C is larger, what is that number equal to, based on our picture?
I don't understand.
Okay.
Well, I guess
This is a key part of coordinate geometry, so we want to make sure you understand this. That's C right there. This point right here is B on the x-axis. So what's the difference between those two? Isn't it the small dimension on the triangle? In other words, this 6, that is the distance from here to here, which we figured out based on the Pythagorean theorem. Remember that all these triangles that you draw on the XY coordinate axis are almost always right triangles.
Okay.
Okay, so we know we have a right triangle that is a 10 and an 8. We got that directly off the coordinates they gave us. They told us the 10. We were able to get the 8 from the 5 minus the negative 3. So now, using the 3, 4, 5 right triangle, we were able to get 6 as the difference between this point and this point. And the key thing to recognize is that that number is C minus B.
Okay.
Okay, because that would make a rectangle. Everything is rectilinear when you're working here. So this C minus B is the same as this C minus B, which is 6. So these two quantities are equal. All right. Down to the hardest, but I think it is. For me, I mean, everybody's different. I have my strong suits in math and my weak suits in math. And oddly enough, and I say oddly enough because I've been around probability all my life, it's actually not one of my strongest suits.
It's not one of mine either. Neither is, as you can tell, coordinate geometry.
Well, of the two, the coordinate geometry is going to be more important. I'm not positive about that. Maybe I shouldn't say that. I think you're going to run into coordinate geometry problems and slope problems much more than you will probability or counting problems. This section is called counting and probability.
Okay.
Okay, this first question is fairly straightforward.
Okay, it looks like it's taking her 2 minutes per problem. So sorry, I'm dropping things.
All right.
So 58.
Good. The key being to know that you have to add 1 when you subtract these two numbers. 20 minus 6 is 14, but there are actually 15 problems there. 57.
I learned that from you, and I remembered it.
Yeah, 57 minus 29 is 28, but you have to add 1, 29. 29 times 2 is 58. Now, this one may require a little more time.
With this one, would I multiply 3 times 2 times 7 times 8?
You'd be close. What number does that give you, and is that one of the answers?
That's 336.
Yeah, so they put the trick answer on there. The reason that's not the correct answer is because it's consisting of a soup or salad.
Oh, okay.
If it said a soup, salad, sandwich, 2 drinks, and a dessert, then you would have done it correctly. And usually that is the correct answer, is just to take all your combinations and put them together. So I'm reluctant to spend a whole lot more time on this problem, but there are 5 soups and salads, which you have a choice of 2. So it's a combination problem. 5, choose 2. Have we done these?
We haven't, but I've worked on them a little bit on my own.
Okay. So the harder questions on this are probably going to involve combinations and perhaps permutations. Do you know how to calculate 5, choose 2? This is usually referred to as 5, choose 2, whereas this would be 5, pick 2.
Yes, I would put 5, it'd be 5 times 4 times, yeah.
5 factorial.
Divided by 5, I can't remember what to call the
Well,
sign.
this is n factorial. In other words, here's the formula. N choose r is equal to the top is the n factorial, and the bottom is n minus r factorial, and then there's one more thing, and the way I always remember it is I know the answer has 2 n's and 2 r's, so it has to be the r.
Okay.
Okay, so in our case here, we have 5 factorial divided by 3 factorial times 2 factorial. And that is, well, the easy way to do it is to cancel out the 3 factorial with everything but the 5 times the 4. So now we have this. You see what I did on that step?
Yes.
Okay. And then that's equal to 10. 20 divided by 2. So there's actually only 10 ways that you can pick a soup and a salad.
Okay.
The order doesn't matter, and the difference between combinations and permutations is in permutations order matters, in combinations order doesn't matter. In other words, you don't care if you get this soup and this salad or this salad and this soup. It's the same when you take it back to your table and eat it. So it's a combination problem, not a permutation problem.
Okay.
So that's for starters. So the answer ends up being, and it's clever in their answer, they say that with 3 soups and 2 salads, there are 10 ways you can put that together.
Okay, so it'd be 10 times 7 times 8. Is that correct?
Yes. No?
No?
Because you can get coffee or tea. In other words, there's actually 2 drinks available also.
Well, I definitely would have gotten this one completely wrong.
This one's harder. Let me just check this answer here. Make sure I got it right. Okay, here's what they say. Yeah, the answer is 560. Is that what that is? No. Why is it not?
They don't put the tea and coffee in it.
Well, no, their answer is 5 times 2 times 7 times 8. Okay, you can choose soup or salad in any of 5 ways. I did that wrong. Let's go back. This was not a combinations problem. I apologize for that. It's probably worth going through the counting process here.
Okay.
Let's just look at it because this can be, we have soup 1, 2, 3. We have salad 4 and 5. Those are 2 salads, 3 soups. How many ways can we choose these? Let's list them all. Since there's only 5, now that I know the answer, there's only 5, it becomes feasible to list them. So what are our combinations? Let's say we have soup 1. This is the first choice. We get a soup and a salad.
So 1 and 4.
Okay. What's another choice?
1 and 5.
And do these methodically.
Okay,
By
2,
that
4.
I mean, once you've found the order, yeah, stick with it.
And 2, 5. And then 3, 4, and 3, 5.
So how do they get 5? I get 6. Did I make a mistake?
No. I think that's why neither one of us like these problems.
Them included. They got the answer wrong. In the answer choice, they say there's 5 ways to choose a soup and salad combination.
Yeah, and there's actually 6.
There's 6. So the answer should be 6 times 2 times 7 times 8. Is that answer on there?
Yes, it is. It's E672.
Wow, and they say D is the correct answer. Boy, nothing like messing up your hardest problem. Yeah, like I said, I didn't want to spend too much time on it. I just didn't know why at the time. But actually, it was rather instructional. I think it was instructional because having to take this and turn it into a combination permutation problem is tough. As you can see, I didn't do it correctly. I came up with 10, they came up with 5, and the correct answer was 6. So these can be tough. But as long as you spell it out, in other words, as long as it's a small enough number that you can list out all the combinations and check them to make sure they all make sense, that's the way to go, I think.
I do too.
It's like how many different ways can 3 letters be arranged? A, B, and C. Now you could look at that as, okay, let's see if I can figure out, is that 3 choose 1? Is that P or 3 pick 1? I don't know, but list them out for me.
It would be AB and AC and BC.
And that's it. So I think that's probably your best strategy. I don't think you're going to encounter too many problems where these numbers are so large that you can't list it out. Now, in this case, it was too large to list out all 672 combinations for sure. But the difficult part wasn't handling the 8 desserts, 7 sandwiches. The difficult part was handling the soups and salad combination, because you could only get a soup or salad. So okay, that's the only part we really needed to list out. And then knowing that there's 2 drinks. Okay. Whoops, hold on. This is a little more of an easier counting problem. Oh, gosh. When I looked at this, I said they're going to ask us how many days are in between those two dates. That's a fairly difficult problem, but very doable. But it's not even that hard. How old was he when he died?
79?
How old is he? How old is he on this date right here?
I'm sorry, he's 9.
Okay, and we got that by subtracting that minus that, not adding 1 or anything.
Right.
Okay, so on 10/14/69, he would be 79.
Right, he would have been 79. He was 78.
Okay, and that's, I think, the best way to do that problem. Is figure out birthday to birth date, what his age would be, and then does that come before his birth date or after?
Or after, okay.
All right, well, we got, I don't like this problem, but how many 4-digit numbers have only even digits?
I don't even know where to start.
Right, because if we were to list all the possible 4-digit numbers, we would go up, and the last one would be 9999, right?
Yes.
And there's not very many in that list of 9,999 numbers where they're all even. So we have to view it as a probability problem or a counting problem. Let's start with this digit right here. How many possibilities do we have there?
Well, we have up to number 8.
So there's 5 possible numbers that can go there.
Oh, okay.
How about here?
There will be, we can still use the same numbers yet, so 5 and then 5 and 5.
Ah, that's the tricky part. The first number can only be 2, 4, 6, or 8.
Oh,
Only
okay.
4 possibilities there.
Okay.
So the answer is 4 times 5 times 5 times 5.
I would never have gotten that.
Well, I don't like this question because who's to say that this isn't a legitimate answer? In other words, can you really exclude 0 from that first digit? And in their book, they do. But, I don't know, that looks like a legitimate four-digit number to me.
It does to me too.
But I don't know. I suppose if you exclude unnecessary zeros, it's not. So if I have a license plate and I'm allowed to have numbers in the first 3 columns and digits or letters in the last 3, how many different license plates can I have? In other words, this spot, and this spot have to be numbers. These 3 spots have to be letters, which is a requirement on license plates.
Okay, so we'd be able to have 0 through 9 on the first.
And you can have duplication.
So 10, 10, and 10.
And how about the letters?
I take it we can go A through Z.
Yeah, so 26, 26, and 26.
26.
So the product of those 6 numbers is the answer.
Okay.
Okay, let's change the problem slightly. What if you can't have duplication? In other words, then you've got 0 through 9 there, but now you only have 9 choices there, you only have 8 choices there, you still have 26, 25, 24, and this would be the product of these 6 numbers.
Okay.
Okay, so that's kind of the way you do problems like that.
Okay.
Just like that one we just encountered. It's always going to be the product of all of those. All right, why don't we end with question 4 there.
Okay.
So we will definitely get done with counting and probability in our next session, and that'll leave us 2 sessions after that. Is my
yes.
Yeah, 2 sessions to do however many tests we can try to do.
Okay, that sounds great.
Let me ask you one thing, Angela. When are you planning on taking the test?
I've moved it to September 21st.
Okay. How long of a test is it, time-wise?
It's 4.5 hours.
At some point before you take that test, you need to start working on your duration. In other words, if we have nothing but 1-hour sessions, even though you're learning a lot of math, it doesn't prepare you. It would be like if you had a 10-mile run to run and we were out running 100-yard dashes all the time. That's not going to prepare you for a 10-mile run. So my concern, you can address this however you like. We could have our last 2 sessions as 1 2-hour session and just, intensify that. But even if you're working totally on your own, make sure you put in some intense, long-houred sessions. That's what I would suggest. You and I don't need to necessarily work on it, but just some advice. You want to have your duration built up because mentally this will really grind you down. You're going to mentally be completely exhausted. Have you done a 4.5 hour or a 4-hour test all at one time?
I have. I've taken a few of. I've actually started taking one every couple of weeks.
Good. That's perfect. That should completely do it. So, sounds like you're already doing what I was suggesting.
Well, thank you for bringing it up because if I wouldn't have been, that would have been good to know.
Yeah, I think so. I mean, it's like anything else. I mean, your mind can turn to mush after a couple of hours, and I'm sure it probably does. I'm sure the last 2 hours of your test, you're not going to be as sharp or focused or as you were the first 2 hours. But that's something we just have to live with. It's like if you do run a marathon, those last few miles are tough, I'm sure.
Right.
Okay. Well, let's see. Our next session is next Thursday, right?
Yes.
I will talk to you then.
Okay. Thanks, David.
All right. Bye-bye.
Bye-bye.